This is the list class in C#. Most people think it's just a dynamic array, but there's a lot more going on under the hood. Have you ever wondered how a list actually resizes? If you care about understanding why the code works and not just how to use it, this is the video for you. Today we'll be doing a deep dive on how lists work in C# by creating our own string custom list. Before we get to doing the code, let's just talk a bit about the behavior of lists in C#. First, lists are a collection data type. This means that they're capable of grouping data of the same type, adding, removing, and giving item access to the data, and growing their collection size dynamically. So let's jump to our custom class. So just to preface, this is our custom list, but it will only be dealing with string classes for now. This can be expanded to deal with other data types, and the full functionality would be using generics, but that's a bit outside of the scope of this video. So let's just talk about the properties that we need for our class. The first thing that we need is an array of items, or a string array to essentially hold our items. The next thing that we need is our size, which tells us the number of items in our list. And that's all we need so far. Let's talk about the constructor when we initialize the object. All we need to do is just initialize the items array when we initialize this object. So we'll do items equals array dot empty string. As we initialize it right away in the constructor, it means that we don't need to worry about null checks. Having it at the length of 0 also means that it almost takes no memory to initialize it, but it also means that we're also doing lazy allocation. We're not assigning any memory to this items array until we actually get to using it in practice. With that said, let's talk about dealing with the resizing or the capacity. So we'll need a capacity property. So let's do our getters. It's going to be items, not length. So just so that there isn't any confusion, this size property tells you the number of items that's currently in our array, and the capacity is the number of items that it can hold. So that's our getter property. The next one will be our setter. So whenever we assign a value to capacity, the item array should be resizing to whatever is specified. So we only need to resize it if the length is different. So it also means that we'll need to resize it. So if you actually think about it, you can't actually change a existing array size. If you wanted to resize it, you essentially need to create a new array and assign it to your existing property. Yep. So we're assigning our new array to the items, and it also means that you want to keep all of the data as you resize it as well. You need to copy all of the data across into your new items. Copy items, new items, and size. Cool, so that's the first part. There's a reason why I did values bigger than 0, because the other scenario we need to deal with is if they pass in a negative number. This essentially means that the developer normally wants the item array to be eliminated or wiped clean. And so in that case, we just do items equals array.empty. And that is done. So we can actually demonstrate this working in practice. So string custom list. Yep. And we're going to assign the capacity and change it to any arbitrary value. So let's change it to 10. Okay, fantastic. So let's actually run and have a look at how this works. So from the constructor, the item would have initialized to an array of 0, which we can see here. The moment we set it to 10, what should happen to the capacity is that it'll be set to 10, and the code in our capacity setter will also change the size of the array. So we have 10 elements here, which we can assign to now. Fantastic, that's the resizing done. Let's talk about the code adding new items. So we're going to do public void add string item. Let's think about this logic for a bit. If our capacity has enough size, we can just assign the item directly to the end of the list. If it doesn't have enough size, we'll need to expand the size so that it can deal with the logic or deal with the additional items. What I'll do first is I'll copy all the variables locally. Size equals size, and its new size equals size plus 1. If we do allocate an item to our list, we would increment the size by 1. So let's deal with the first case. If items.length is bigger than the size, then size will equal new size, and items size equals item. If we do have enough space here, if it is bigger than the size, it means that we can now increment the size by 1 and assign the item to where the size was, or where the index is, the last item in the array. Do note that this is size here, and this is underscore size. This size was the last value that we captured, and because we're indexing from 0, this is assigning it to the right place. So that's the first part of it. The next part is going to be dealing with the resizing. Now, what I'll need to do is I'll actually need to create a default variable for a capacity, and you'll see why I do this in a bit. So private const int default capacity, and let me do the code for the resizing now. Int new capacity equals items.length 0, default capacity is 2 times items.length. So this new capacity here is the value that we're going to be assigning to our capacity property that changes the array size. And the thing is, we're checking if the item's length is 0 first, if there are no items. If there are no items, we're going to give it a value of default capacity, which is 4. Otherwise, we'll just expand or multiply the list by 2. So you might be asking why we're multiplying it by 2. Why is that our logic for expanding the array? Well, we could handle it multiple other ways. We could just dynamically resize the array per item we add, but it's not very efficient as we keep constantly changing the array size. We could multiply it by 3 or 4, but that would be a waste of memory because it's not the case that we'd use all of that memory yet. If you actually think about it in terms of big O, this efficiency is at log of n, and you'll see that in a lot of other programming languages, this is how the resizing is done for these type of collection data types. So there's also one other thing we need to deal with. If the new capacity is less than new size, then we need to assign new capacity to size. So essentially, if for whatever reason the new capacity still can't match the size, then we just assign it directly. We could hit the scenario, but it is a bit rare. So capacity equals new capacity, size equals new size, and items size equals item. Yeah, so the moment we assign our new value to capacity, it'll automatically resize the array, and then we set our size and our item. So let's actually test that logic. So let's get rid of the capacity, we don't need that. So string custom list dot add apple, banana, carrot, durian, elderberry. I'll execute this now. So at this instance, string custom list won't have any values yet. So the moment we go over this line and add apple to the list, it should expand to an amount of 4, and we can see that in capacity is 4. The item is at 4, the number of elements is at 4, and you can see now that the size is at 1. We step to the next one. Item has been added to the end, and the size is at 2. Let's jump to the last one here. So we can see that all the items are now filled out. So what should happen is if we add this fifth item in, it'll expand the list over and multiply it by 2. So it went from 4 to 8, and we can see elderberry has been added. So fantastic. That's the adding code done. Let's talk about the accessing code. So we're going to be using a thing called indexing to access our properties, and I'll show you how to do that. String this, index. We set our getter properties, and we get our setter properties. This is called an indexer. Whatever value we pass in here, it'll access whatever property we've tried to access beneath here. So our getter property will access items for that index. Our setter will assign the value to that item for that index. So I can show you that in practice. So let's say string custom list, and we'll access the first element. We'll say this is equal to orange. And I'll show you that you can also get the property as well. So we do get property equals string custom list, and we'll just say 1. Oh, maybe 0. The first element right now, the second element, is banana. That will be changed to orange, which you can see here. It's been changed to orange. If we go pass down this get property line here, the first item is apple. So if we go over and hover over get property, we can see that the value of apple has been assigned to a variable. The final thing we need to deal with is the remove functionality. So do the remove code public void remove app int index. So what this code will do is it'll just remove the item at the specified index. So if we think about the logic, the first thing we actually need to do when removing an item is reduce the item, reduce the size. And then we check if the index is less than the size. Because we can only remove a property, that's within our range. And then what we do is we do array.copy. Plus 1 items index size minus index. Fantastic. Yep. And lastly, we need to do items size equals default. For array.copy, essentially we're removing the item at the specified index, and we do that by moving all the items after it back by 1. And by doing that, we essentially are removing the index, removing the item at the index, but the last element will still be present. So if we do equals default, which is the default value of a string, or whatever is specified for that array, it'll remove essentially the last item in this case. So we can actually test that. So string custom list dot remove at 1. Yeah, we'll do both 1. So let's have a look at our code. The element at 1 is going to be orange, so this will be removed. So you can see orange has been removed and it's all moved back by 1. We do it again. And you can see carrot has been removed. So fantastic. That is the main premise of how lists work in C#. For your reference, what you can actually do is you can actually dive into the list class and have a look at how they've implemented a few things. So they've had the default capacity, they had item size. You can see that they've initialized an empty array variable here, which is new t0. Specifically, they have things like checking for the range when they're doing indexing. So it means that you can change the default behavior of how the lists work if you need to. So yeah, that's how lists work in a nutshell. I hope you enjoyed the video. Like, rate it, and subscribe. Thank you.